Okay, problem number 16, we can solve this one any method we want. It looks to me like it's all ready and set up for elimination, so elimination is what I'm going to use. I'm going to get rid of those those x's, I think. So first of all, what you need to see is that this x and this x need to go together. So I'm going to multiply the top equation by a -4, and I'm going to multiply the bottom equation by a +3. So -3 times 3x plus a 9y equals -21. Just +21 equals +21, just like that. And this 3 times 4x, and I'm going to line up the x's this time so I don't get confused, and the 12y, and that equaling the +32. And now I can go ahead and rewrite these things. So I have a -12x and a -36y, and equaling a -84. And then in the bottom I have a +12x and I have a +36y, and I have a positive, and that would be 96. And when I go to add these, I see that this side is 0, just like I wanted it to be, but the y's are also 0. So I'm going to write in a 0 there so I don't lose my equation, and then 96 minus 84, which is 12, and it's a +12. This is a false statement. Anytime I get a false statement, that means that there is no solution. So we don't just write false. We don't say that this is inconsistent. We say that there is no solution. That is actually the answer. All right, now moving on to the next one, which is our word problem. We want to go ahead and take a look at this word problem. So it says Sally has 3 adult passes and 4 child passes. So what we have is adults, and we have child passes going on. So I'll write that fact down. And for the mass transit in Metropolis, Jack has 2 adult passes and 3 child passes for the mass transit in Metropolis. Sally paid $118 and Jack paid $84. How much do adult passes and child passes cost? So we have the cost, right? Adult cost and child cost. Those things are the things that we're gonna that are going to be unknown. And so what we have are 2 scenarios. We have a total value for a child, which would be the child cost times the number of children. And then we also have the total for an adult, and a total for an adult is going to be equal to the adult price times the number of adults. And so what we have going on is we have Sally total being that she has a child total child, and a total adult. And I'm just abbreviating these very briefly so I don't have quite so much writing to do. And then we also have Jack, and Jack's total, his being, again, a total for a child, and the total for an adult. And we're told that Sally spent $118, and we're told that Jack only spent $84. And we're also told that Sally and Jack have a certain number of kids and a certain number of adults. So we have Sally child and Sally adult, and then we have Jack child and Jack, adult. And once we get all those numbers, we can put all that information together in what we've already built to form an equation. So child for Sally was 4, and adult was 3, and for Jack, he had 2 adults, and he had 3 child passes. So Sally's total, the total of the children, was how many children she had times the number of, or the price of the child's pass. Well, these are the things we don't know, so this is where I'm going to fill in variables. So child, I'm calling y. So Sally's, I'm going to write Sally's equation in blue here. So we're going to have Sally's equation looking like the total child. So that's the child value, which is y, times the number of children that she has, which is 4y, plus the total adult pass, which is the number of adults times the adult value. So the number of adults for Sally is 3 times the x value, and that was $118. And then we have Jack. I'm going to put Jack in pink. That's backward, huh? I'm going to put Jack as the total child. He had 3 children, and the value for a child is y. And then plus, he had 2 adults, and their value is x, and that gave him $84. And then what we want to do is we want to solve this system that we've created. So again, these things are set up very nicely for elimination, so why don't we go ahead and just solve it through elimination. So what I'm going to look at here is I'm going to look at adding these together, and we're going to and then going to eliminate one of the variables. I'm going to choose to eliminate the x. So I'm going to multiply this equation up here by a 2, and I'm going to multiply this equation down here by a -2. So with that said, I'm going to get a positive 8y, and I'm going to get a positive 6x, and then I'm going to have twice 118, which is going to be 236. And then I have a negative 6y plus a negative, oops, that's not 6y. Sorry, I'm multiplying by the wrong number there. That is not a -2, but a -3. I need to make them both 6. So -3 here. So this one is, again, not a -6, but a -9. So I'm going to have a -9 there. And then a -3 times a -2, which is going to give me a -6, and those are x's. And then I have 3 times 84, so 3 times 4 is 2. Carry the 1, 25, so this is 252, and it's negative. So adding these together, I'm going to get a -y, which is equal to 252, so 252 minus 236, and that's going to give me a -16. Now, because they're both negative, divide them both by a -1, and that's going to give me that my y value is equal to $16. So what does that mean? Well, that means that my child tickets are going to be worth $16. And then I can take that $16 and put into either one of my equations, and I can solve for the resulting x value. We'll have to do that over on the next page. So we'll have 4y plus 3x is equal to 118. I believe that was one of my equations. 4y plus 3x equals 118. 4y plus 3x equals 118. And we just found y to be 16. So we'll put that in for the value. So 4 times 16 plus 3x is equal to 118. And so we have 16 times 4, so we have 4 carry the 2, so that's 64, and we're going to add the opposite to both sides. So we have 3x is equal to 8 minus 4 is 4, 11 minus 6 is 5, and then we multiply by the reciprocal, which looks like division because it is here and here. 3 will go into 5 one time, and 2 left over, and 24 8 times, and so $18. So it's $16 for a child and $18 for an adult. And that will be our final answer and the end of our lectures for this one. Now, I also recommend that you don't forget about the following. So let me briefly remind you about some problems that you need to be aware of for your test. Don't forget about simple interest problems. Remember the formula principal times rate times time is equal to interest. So that looks like P R T equals I. And remember, we solve problems like that. And when we also had chemistry problems, and we solved two equation, two unknown chemistry problems as well. And I want you to be sure that you review those so that you can see how to do that. The chemistry problems, we had percent of the volume was equal to the pure whatever it was. And we had two instances of this and a third instance for a mixture. In these equations, we had two instances of using the principal times rate times time to get interest. The principals added up to give us an equation, the interests added up to give us an equation. Here the volumes add up to give us an equation, and the amount of pures add up to give us an equation. So those were the two problems I want you to be sure you review, because two of those, oh well, there's one of each of those on the test, as well as one that's a total value problem. The test total value problem is a little easier than this one that we have going on in problem number 17, but it's still a total value problem. All right, that wraps it up.